Okay. Uh, Happy Tuesday. How's everyone doing? So we have three more content-heavy classes. I'm not sure what's going on with the white noise. I fall asleep to white noise. Hopefully you don't in class. So we have three more topics to cover. Today we're talking about interaction terms, which is not going to take the entire class period. So the way we're structuring the class, we're going to talk about the model. I'm going to show you how I would set up a model to test the question at hand today. And then we're going to essentially treat this as a final project. So we're going to start, working with data sets that I'm not hosting on my website. So we're going to download this data set. We're going to run it in Colab as if I didn't have a website to run this from, just like you will in your final project. And then we'll probably have a few minutes at the end of class. There are lots of questions right now about final projects. So I want to give a second to just have as many conversations as I can about your final projects after we get through the material today. So that's where we're going today. Thursday, we're talking about one more extension of the general linear model. We're going to introduce not just categorical controls and interaction terms, but we're going to include numerical controls. So this will be one additional extension of the bivariate general linear model, which we're building right now. Then next week, on Tuesday, we're going to talk about model selection. So how do we pick between these different models, which you're going to encounter in your final project, like how do you choose the right model. We'll talk about causality, which is everyone's favorite topic. I'm going to show you an example, really fun one. And then Thursday next week will be our last mini exam. So that'll be essentially 2 weeks after mini exam 4. At least that's what I have scheduled. I'll let you know if that changes. So that's where we're going. And then after we get through mini exam 5, we're in part 6. So this is thinking about communicating with data. There's no mini exam for part 6. The assessment is the final project. So we'll talk about best practices for communicating with slides. So how do we put slides together that we can communicate to an audience in the way I do every day. And then we'll also talk about how to write short papers, just really brief summaries of our findings from data. These are things I think as college students you have a lot of exposure to and experience working with, but I want to give you a different perspective how we do this primarily with data. This is not a writing intensive class. You're not coming in here to write huge papers. The presentation requirement is 3 minutes long, which for most people will be 1 to 2 slides. And then the paper itself, I don't want it to be longer than 2 pages. We'll talk more about this as we get closer, but these are some of the main requirements for the final projects, and we'll spend more time talking about them at the end of class today and next week. Can you all hear me? My voice, I think, doesn't carry so well over these kinds of sounds. I don't know what's going on. Is this like air conditioning or? I don't know. Speaking of Maxine, Maxine falls asleep to a white noise, a sound machine every night. So she would be asleep right now. This was on Friday, right as the weather was getting nice. We went out to Friendship Park. Anyone been to Friendship Park? It's like 2 miles from here, pretty close to my house. So how are you all doing? Hanging in there? Lots of thumbs up. You ready for summer? the good news is we don't have a ton of new material to cover in April. We're doing mini exam 5, so we're covering the part 5 material. We're talking about putting together final projects, but that's the big focus for the remainder of the semester. We've done the real hard work. Let's see. You'll want to start off with what we're doing today. So last class, we talked about categorical controls. So often we think about relationships between variables. That was our part 5. We talked about Simpson's paradox. So sometimes the top line result isn't what we expect, or it doesn't tell us the whole story. Sometimes we have to dig into the details. And what we did last class, I think the big thing after the mini exam, obviously, was start building this model of the gender wage gap. So I gave you a data set that comes from the census of 1,000 observations, and we talked about whether there were differences in wages by gender. And then we also talked about whether there was a difference in the gender wage gap after we controlled for returns to education. So we checked in our data set whether people with more education make more money. It turned out they did. And then we saw that the gender wage gap persisted even after we controlled for returns to education. What this allowed us to do was compare two people with different genders, the same levels of education, and check for those two people, on average, is there a gender wage gap? And it turned out that there was. So the picture we had at the beginning was something like this. So we break out by gender on the horizontal axis. In the census records, we have two categories. The way the census is set up, unfortunately, asks you for it only gives you two options. So that's what we have in our data set. I'm going to show you what this looks like in a second. But this is the data set we have at our disposal. So this is how we're setting up the gender wage gap with two options. So we have female and we have male. And then what we did is we walked through thinking about our core categorical predictor model. This is very familiar from part 4. We just have two groups. You can think of this as a slope between the two groups, or you can think of it as a separate vertical intercept, which in this case is helpful to think through. So what we said is the vertical axis, our beta 1, is just the difference between the genders. And we used this as our model. We're predicting wages using beta 0 times beta 1 times male. These were our interpretations. Sometimes we call these categorical control variables. We call them fixed effects. And then what we did is we went through and built a model implementing the basic gender wage gap, just checking whether there were differences. But like we talked about with Simpson's paradox, sometimes the top line result isn't, it's more nuanced when we dig into the details. So what we did is we controlled for education. We know there are differences in who goes to college, and so historical differences and current differences. And so one thing we might be interested in is whether two people with the same levels of education, but different genders, still have a gender wage gap. So what we did is we built this model. We said, we're just going to predict on the horizontal axis years of education as our predictor variable. And then we're going to use wages as our outcome variable, the thing we're trying to predict. So we ran that model, and we saw that there was a meaningful increase in one's income associated with extra years of education. We said this was not necessarily causal, right? We don't have enough information in our data set to know whether choosing to go to college causally impacts your earnings later. We would expect that it does, but we just don't have evidence of it in we don't have enough control in our data set to be able to identify that causal relationship. What we do know is that people with more years of education have higher incomes. But this could be for lots of other reasons, like wealthier people tend to go to college more, but the wealth from your parents tends to impact your later earnings. So that's a channel, like a story that's unrelated to education. Your parents' income could be impacting both education and your later earnings. So it may not be a causal story. We're going to talk about this next week. So we're going to build like frameworks for thinking about causality. But for our present purposes, what we wanted to do was check whether there was a difference in earnings by gender after we've controlled for years of education. So we remembered back to the very last visualization tool we had in part 2, which was our scatter plot by category. We built that for this purpose. So we have 2 groups, and we're just coloring them with different colors. And then all we're going to do is build a statistical model with lines going through each of the 2 groups separately. So what we did here is we said we're going to include the gender wage gap on the vertical axis, but what we're going to do is also draw parallel lines through the data for both groups. And what this does is gives us the ability to separate on the vertical axis wages, while still allowing us to control for education. So we have a slope that relates wages with years of education. And we do this for both groups. But it also allows the lines to be different. At this point, they're still parallel, but we have different intercept terms by gender. So this is essentially extending the first picture we had, but allowing there to be a control variable for education. So this was the model we built last time, and we took this to some actual data. That's where we're going to pick up today. So this was the model we ran. We said we're going to predict wage using some vertical intercept, beta 0, which is the vertical intercept for our 0 group. So everything else is 0. So if education is 0, you have 0 years of education, and you're 0 in the male group, which the way we coded this last time was female. So we said, if you're female with 0 years of education, your base wage is beta 0. And then we included extra controls. So this was beta 2 was the difference between being 0 or being 1 in our male indicator variable, which meant 1 is male, so we had a gender wage gap. So we walked through how we interpret this. We're going to talk today more about how to interpret log variables. It's an important part of how we run analysis, particularly with incomes. We've talked about logs early, and now we just need to talk about interpreting coefficients with logs. Okay, so that's what we did last class. What we're going to do today is start from a slightly different place. I want to show you how I would do this if the data wasn't hosted on my website. In the notebook, I usually just give you a link to the data set, which you can just load directly from my website. But for your final project, many of you are starting with your own data sets. Some of you are using the data sets from the projects page on the course website. So you can find, under projects, you can find lots of different projects from previous semesters. So this group, JJ and John V, they this is just a replication notebook for their project. And what it does, I actually, after the semester ended, I actually started hosting their data set on my website. So if you want to use this, here's the link. And you can find this link for every project that I've posted on the course website. So if you want to use a similar data set to what someone else has done in the past, you can find the links here. And you can just go through and replicate what they've done. I've gone through and summarized some of their findings. So this is not exactly what they ran, but it's very similar and replicates their main findings. So you can take a look at any of this that you like. But let's say you're not using a data set that's from my website and you want to run it for your final project. That's where we're going to start class today. So I'm going to say I have a data set that I'm interested in from the census, and I want to run this in Colab. There have been lots of questions about this, so I think this will be a good place to start. All right, so that was from last class. What we're going to do today is build a slightly different model. One question you might have, in addition to is there a basic gender wage gap, is are there different returns to education by gender? Which I think, for me personally as an educator, is an important question, and we have the data to answer this. So what we're doing is building what we call an interaction model. So not only are there different slopes, or different intercepts by category, but are there different slopes? This is the question we'll ask today. Are there different returns to education by gender? The picture you might have in your head goes something like this. This was the data set we had last time, the picture of a data set we had last time. We have two groups. Horizontal axis is years of education. Vertical axis is earnings, which unfortunately I still haven't labeled. And our question is whether education is associated with higher earnings, but differently by group. We have the data to answer this question. All we need is the tool set to be able to do it. This is what the picture might look like. This is going to be model 3. So we built model 1 and model 2 last class. We're going to call this model 3. This is different returns to education. Here we're going to have a vertical intercept term, but we're going to, in model 3, we're going to say the intercept term is the same for both groups. This is a modeling choice I'm making, and we're going to relax this in model form. We're going to allow both different slopes and different intercepts in our next model. But just to keep things simple for model 3, I'm going to say we have the same intercept. So there's no gender wage gap for people who don't go to college. But then my question is whether years of education, I should say 0 in this case is years of education. So with 0 years of education, there is no gender wage gap. That's the model I'm building. We're going to relax this in a second, but that's the basic model. But then my question is whether the returns to education differ by group. So we're going to build 2 slopes, one for each group. And it's going to look, the picture I want you to have in your head looks like this. So for the 0 group, we're going to have a slope of beta 1. So this is our 0 group, which in this case is female. And we're just going to estimate for the female group the returns to education. But then in addition to that, we have a 1 group, which we're going to estimate separately an additional slope. This could be positive, this could be negative. We're not assuming it to be any sign coming into it. What we're doing is allowing there to be a separate slope for each group, which looks like this. So horizontal axis is years of education, and then vertical axis is wage. And then the way I want you to think about these models is that we're literally just drawing lines through our data. The slope of the line, the control we have over how many lines and how they slope. That's what we're doing in part 5. Okay, so any questions about this? So to do this, we have to add a separate slope for the one group. So if you're in the one group, which the way I've coded this is male, then I want a separate slope for that group. The equation you can use for this looks something like this. We have beta 0, which is our vertical intercept. So this is the average wage for anyone with 0 education, and 0 education in this case also means that beta 2 will be 0. So this second term will also be 0. But then, in addition to the beta 0, the vertical intercept, we have a slope term. So this is how education relates to wages. So this allows us to increase education, just like we did in standard numerical predictor. It just gives us a slope between our two numerical variables. But this is all for the 0 group. So in this case, when male is 0, then this term is not present. To get a second slope, so to have a second slope variable, beta 2, we need a specific intercept term, a specific slope term connecting education to earnings for the one group. So in addition to everything else we've built, beta 0 plus beta 1, we also need something specific for our one group. So when 1 is turned on, is there some extra slope associated with the relationship between education and earnings? Okay, so this is the equation. Are there any questions about this? You're going to get some experience building these models in Homeworks 5.1 to 5.4. So I will be asking you to make these models. But the basic idea is just like this, right? We're just drawing lines, and then we need specific slopes and specific intercepts by group. All right, so this is our model. And the way we interpret this, beta 1 is the returns to education for the 0 group. So if you're coded as 0, beta 1 is just that specific slope. And then beta 2 represents the additional returns to education for our one group, which in this case is male. So there's an additional return. This could be negative, so it may not be that there's higher returns to education for male, but it just gives us the ability to have a separate additional slope. So then to get the returns to education for the male group, we have beta 1 plus beta 2. So we have the core component for everyone, and then we have the additional for the one group. So we interpret that as beta 1 plus beta 2. Okay, any questions here? Are you starting to see how powerful this model is? This allows us to do almost anything you like. All we have to do is correctly draw the lines and then turn those lines into equations. Okay, so let's just write some. Let's run some code with some data. This is the equation. This is how we run interaction terms. So this is our log income. Then we're using education to predict income. So this is the relationship between education and income. But then we want an interaction term. We want to say, I want a specific return to education for my different groups. And the way we write an interaction, so multiplying education times gender, or male in this case, is with this colon. But then everything else looks identical. So this is what we're going to run. This will be our model 3. I'm also going to show you model 4, which allows there to, in addition to different wage paths, we'll have different intercepts. So the vertical axis will also be different. But the core model we're doing today is 3. All right. So I want to show you a few things. This is where we're leaving the slides for a second. If I'm interested in using census records, there are a couple of places for me to go. The first place I would start is going to projects. I have a link here for data sources, which is just a long list of data sources I would use. Some of these are recommended from students in past semesters. So I've had students find really interesting data sets, and I posted some of them here. I think most of you at this point are already have a data set that you've worked with for a couple of months now, off and on, but at least a little bit of exposure with. But I know some of you are still sort of finalizing some of your final project ideas, which is totally okay. You could even change last minute. You're not locked in. These are just some data sources. The Federal Reserve of St. Louis keeps track of lots of economic data sets. So if you're interested in like CPI, this is the Consumer Price Index. So macroeconomists track these things. Essentially measures of inflation. So if you're interested in that, which is a hot topic right now, you can find that data set here. You can also find measures of like GDP, these kinds of things, unemployment rate, how much money is in circulation, exchange rates, and so on. Lots and lots of interesting data here. You can also find census records. Well, let me show World Bank. So this is lots of data here on lots of different things. You can search for lots of different variables. We've used GDP by country in this data set, in this class, a couple of times. I think in part 2 we did it in a couple of ways. I got that data from the World Bank. So lots of things you can find here. There's Bureau of Labor Statistics. So if you're interested in this, lots of it's another place that hosts data sets like inflation and prices, which you can get some of this from the Federal Reserve, employment and such, unemployment, just lots and lots of data here. In some ways, it's almost overwhelming how much there is. Some people use Google Trends, so you can just look up like how economics as a term has been used over the last let's say 5 years. Maybe more relevant now, but these are just like how Google searches have trended. So you can search any term you like there. You can even break it out by geography. So there's lots and lots of data sets here. People have used sports data. Zillow has property values, so you can download information about property values. This is used as a research data set, so that's available too. Just lots and lots of data. The data set I want to show you today comes from IPUMS, which is the third on the list. This is where I got the data set that we're using for our gender wage gap example. IPUMS, I've had many students use this before. This is a little more advanced among the different data sets. If you have interest in working with IPUMS, one of my past students, Ruby, for this project used IPUMS data. What their group did is they coded lots and lots of different majors, and they got this the data set from IPUMS. So this is information on earnings and degree field. So we have income total and we have degree field. And what they did in their project is essentially compare different majors to check which make the most money. And then this group looked at their major and then compared it to everyone else. So that was a project they used, and they used IPUMS. IPUMS is, it stands for, let's see, Integrated Public Use Microdata. I don't remember what the S stands for, Microdata Service. But this just collects essentially census records. And it gives us lots of information about this. So here we can create a custom data set, and we can get different variables. I'm not going to go through the whole process here because I've actually done this already. But if you have interest in working with IPUMS, you have lots of data at your disposal. Lots of variables about people individually answering survey questions, census record questions, which is a survey. So yeah, this is a great data set. In fact, lots and lots of data. You can even go historical. I did a project years ago that used historical records all the way back to the early 1900s. So we have census records going all the way back. I notice I'm putting you all to sleep by talking about IPUMS. Can I show you, the reason I'm talking about this is because you're going to be collecting data sets on your own from somewhere on the internet. And this is, I think, my favorite one of all of the ones I listed. It's just the most advanced. So there's not an expectation that you use something like this. But this is where I got the data that we're using for the gender wage gap. So what I want to do today is talk you through how I would get started if I was starting from scratch. So what I have, we have our census records, and I'm just going to download this. This is a data set from the census, which I got from IPUMS. And here you can see what this looks like. So this is, we looked at this in Python, but this is what it looks like in Excel. We just have the year, we have the sample. So this is essentially just an indicator for which sample was taken. But then we have some more important variables. The first one is sex, which unfortunately the way the current census is collecting this information, there are only two choices. And that's all, that's what you choose from. This hopefully will change pretty soon. There's a proposal to make this better. but probably not going to happen in the next 3 years. We also have age, so like the age of the person who's responding. We have their education. So this is, someone coded as female, aged 51, with 6 years of education. We have the degree field, which this means they don't have a higher education degree. And this is their income. So this is right around $40,000. So I recoded education as years of education, which in this case, they had 12 years of education. That's high school. So no college, but some high school, which I recoded from this variable. So this is what we're dealing with. This is not the entire census. You can get that. It's just, it's like 350 million observations. So here I just have 1,000 observations, just to make our job a little simpler. But this, when I downloaded this, when I clicked on this, it downloaded into my downloads folder. So here I have it in my downloads folder, along with all these cute pictures of Maxine. This is all I download these days, just pictures of Maxine before class. So I have this sample here. What we need to do is give our notebook in Google Colab access to this data set. That's what we're going to spend like 5 minutes here talking about. There have been lots of questions about this. For almost everyone in this class, this is the first time you're doing that in this class. I think most people have already done it, but this class will be the first time you do it. I've given you a project template notebook. If you click on this, it opens this template, which just has an outline of sort of my expectations about your project. I'm going to save this in Drive, so I'm going to save a copy in Drive. And then I'm just going to go to where it is in my Drive. So I can locate this in Drive just by clicking on this. And it just loads in my Colab Notebooks folder, which is just, I don't keep this organized. Hopefully you're keeping yours organized, but I have so many classes doing this, it's impossible for me to organize this. But this is my my file. And I'm just going to rename this. I'm going to say final project spring 26, and I'm going to do this for a later class, so I'm going to say 1 p.m. Which just lets me keep track of these things. The even better step is to put this in a folder called final project. So I'm going to say final project 1 p.m. And that creates a folder up here. So what I'm going to do is just, I'm going to move this. I'm going to say organize and then move. And I'm just going to move this into that folder. So now I can just keep my, my files organized like this. I have the notebook in a folder, and all I need now is the data set. So all I'm going to do is, from my downloads folder, I'm just going to drag this into the final project folder. It looks like this. Now, you may not care, but I'm going to rename this just so it's a nicer file name. I just don't want that 2 on the end, so I'm just going to say US sample data. And when I open the project notebook, I want to give this notebook access to my to that US records data. So what I'm going to do is just give the notebook access to my Google Drive. So I'm just going to run this first cell. All this is doing is just mounting the Google Drive to the notebook. And I'm just going to use my personal account, and this just it allows the notebook to access my Google Drive. Now, if I were to look at what's in this in my Google Drive, it wouldn't be pointing directly at the folder that I'm interested in. So I have to change where Google Drive is looking, and that's what this does. I've written this code for you, so it's easy, hopefully. What I have to do is change the project folder. This is looking in Colab Notebooks. I'm going to change the project folder from Zillow to Final Project 1 p.m. So I'm just going to say Final Project 1 p.m. And if I run this, it should load my data set. The next thing I'm going to do is just run all the imports, and then I just want to load the data set directly. So in this case, my file is called usasampledata.csv. So I'm going to say usasampledata.csv. And I'm just going to take a look at what's in this data set, just to verify that we're actually loading this correctly. And it turns out we are. Okay, any questions about this? There have been a lot of questions about this over the last 2 months or so. If you're still having issues with this part, don't hesitate to reach out. This doesn't need to be incredibly challenging or frustrating. If you spent more than 10 minutes on this, come talk to me, and we'll get that sorted for you. Okay, so nice. If you want to do some data cleaning or data preparation, that's where you do it here. The first thing I want to do is I just want to create the variables that we're most interested in. So in this case, that's going to be male. So this is just, I'm going to, it's going to be 1 minus, and then in the data set, it's sex is coded as 0 for male and 1 for female. So I'm just going to redefine it to be this way. But you could, run this with sex as a predictor variable. The second thing is I want log income. I have log base 10 in the data set, but for our purposes today, it's going to be better to use the natural log. So I'm going to say data, we'll do ln income is equal to np.log, but this should be income total. So this is income total. And then if I plot this, it looks like this. Now, some of the things I might be interested in, my main variables are male and education and income. So what I'm going to do just to start is just plot a histogram of some of these variables. First one will be, let's do hist plot, and then we'll do x is equal to, where should we start? ln income, and then data. So this is just a distribution of log income. I think it might be easier to see income total. So if we plot this, this is a distribution of total incomes, and you can see most people make under 100,000, and most people make well under 100,000 in our data set. This is one of the pictures that indicates we should probably be using log income. We get this scaling property where very large incomes are very unusual and most incomes are very small. So if we, we could, plot this exactly like we did before, but with ln income. So just looking like this. And this is a much more natural distribution of incomes because of the scaling property. I think income totals may be easier to interpret. The next thing we want to look at is the distribution of educations. So sns.histplot data, and then I want x to be equal to edu. So this is the distribution of years of education, which when you're looking at this, I want you to, the reason we spent so much time at the beginning of the semester talking about data visualizations is so that we can understand what the variables are telling us. A histogram communicates the distribution very nicely. In this case, it shows us what happens for the people with very 15 years of education. What's that, like 3 years into college? And we actually don't have anyone in our data set of 1,000 observations with 3 years of college. Most people either finish or they end early. Or this is just the way the data is coded. Maybe there's just no way of coding in the census someone with 3 years of college. Showing a figure like this indicates to us what's included in our data set and things we need to think about. Whether the census allows us to code for 3 years of college. But you can see a lot of people have 12 years of education, which is high school. A lot of people have 1 year of college, 2 years of college, and so this would be 4 years of college, and then more than 4. You can see this doesn't go on forever, so probably what this is doing is coding everyone with more than 4 years of college as 5 years. So everyone would be, everyone with postgraduate degrees would be included as 17. But this gives us a picture of the distribution of education. And then the last thing we might want is to know the gender breakdown. So I'm going to use, should we use a bar plot? Flashbacks to mini-exam 1. So let's use sns.bar plot data, and then we'll use, let's put this on the horizontal. We'll do this as male. You can always use sex, but we'll use male. Anyone know what I'm doing wrong here? I'm not sure either. This is only showing one group and it's not labeling it. I'm not sure why that's happening, but you can see the horizontal axis tells us count plot. There we go. All right, so horizontal axis, bar plot is what it's called in Excel. We have count plot on the with sex on the horizontal axis. I think male is the more descriptive variable. So we have 0 for female and 1 for male. And you can see our breakdown is pretty symmetric. It leans slightly towards female, but we're pretty close to 50-50. Any questions about this? So we have 3 variables we're most interested in, which is how we're building our model. And it's best practice to start by visualizing them. That's what we spent like all of the first part of the semester talking about for this purpose. The next thing I want to do is plot, let's do SNS dot scatter plot. And I want the data. I want the horizontal axis. We'll do x is equal to edu. So the horizontal axis I want to be years of education. And then the vertical axis I want to be, let's do ln income. And then I'm going to use hue for male. And then let's just plot this, see what it looks like, see if we have any changes to make. So this is pretty nice. We have, the horizontal axis is education, vertical axis is log income, and then I have two groups, blue for female and orange for male. And this is fine. It's sort of hard to see what's going on though, so one thing I'm going to do is add alpha. So this will just add some transparency. But this is still, not that great. One thing we could do is add some jitter. It's kind of hard to do in a scatter plot, but we can do it. And that would make it easier to see the differences between groups at the different education levels. But I think this is reasonably fine for our purposes. You can generally see that there's an slight upward trend. So the more education you have, the higher you move on the vertical axis. One note here is that in general, your figures are not going to look as nice as the stylized ones I have in my slides. The ones in the slides are meant to communicate nice results very simply. In reality, the data in the world is much more messy. And you can see that here. So then the next thing we want to do is build and run the model. Any questions about this? We can even use LM plot if we want, which doesn't have an alpha, I guess. But this gives us lines through our data really nicely. What this is doing is adding, it's giving us separate slopes and separate intercepts. But the next thing we want to do is build and run the model. So what I'm going to do, I'm going to call this model 3. There's code for this in the slides. What I want to do is predict log income using using education, but I want to include an interaction term. So I want the same intercept term, but I want separate slope terms by group. So this model that Jem and I wrote is wrong. We want education on its own, but then I want a separate slope for my based on gender. So I'm going to say edu, and then we're going to interact this using this colon. So this is essentially a multiplication times male. And when I run this, it gives me a slope for the 0 group, and then a separate slope for the 1 group. So I have the base slope for edu, but then I have this separate slope for those who are coded as 1 in the male group. And when I run this, I get model 3. Whoops, that's not. I need fit, and then I'm going to print out model 3 summary, tables, and then we'll just we'll make it look pretty by putting a print around it. So this is our model. This tells us the returns to education for those in our 0 group, which is female, which is every additional year of education is associated with a 22% increase in earnings. That's substantial. 22% every year. But then we also have this interaction term. This tells us the specific slope for those coded as 1, which in this case is male. So this is an additional slope, and we can see that it's very unlikely to be from our null hypothesis of no relationship. Okay, so we're like 56 minutes in, but I want to ask you a question. My question for you is, how do we interpret this? We've talked about interpreting betas. We've talked about building this whole statistical model to be able to do this. Do you want to chat to each other, or do you just want me to talk at you? I'll talk at you, how about? You've talked to each other all semester. Okay, let's make this awkward. So let me interpret this for you. This is our beta 2, which from our model, that's our beta 2. So this is the separate returns to education for those in our 1 group. And what this means is that we see a difference in slopes, which in my mind is unfortunate, but we can part of the power of what we're doing is being able to observe these kinds of things. So unfortunate, but present, and we can see it from the coefficient and the p-value. So this is telling us the p-value being very small is telling us the probability of seeing something this extreme under the null hypothesis of no difference in slopes. So if the returns to education were identical by gender, we would see something like this about 0% of the time. And then this coefficient tells us that there's roughly this is like 3.4% additional returns to education for those in the male group. So from this data set, if you're coded as 1, then you're receiving roughly 24.5% increase in your income for every additional year of education. So 21 versus roughly 24.5. Okay, so that's the results here. I just want to hop back over to the slides, and we'll talk about the interpretation. There's a reason we use logs, and that's because let's say we give a 5% increase in income to 2 different groups. One has 25,000, so this is a person with 25,000 income. If I give $5,000 of a raise to them, this is a roughly or almost exactly 20% increase in their income. If I give that $5,000 to someone who makes $200,000, that's a much smaller raise. So what we want is a consistent way of talking about increases in income that scales based on where we are in the income distribution, and that's what we do with logs. So basically, economists always use log income. It sort of puts everyone on the same percentage scale. So it allows us to talk about relative percent increases in incomes. And the way we interpret this, so with this model where we're predicting log income, we interpret the coefficients as percent changes. So for example, if beta 1 were 0.08, income, we would say income is 8% higher with every additional year of education. These are not the numbers we estimated, but if they were, this is how we would interpret them. Any questions about this? Nice. I've lulled you all to sleep. These are incredibly powerful tools, as you can see. We're making very powerful claims using real-world data. And the same is true with all of our betas. As long as the outcome variable is log income, we interpret the coefficient this way. So it's an additional 3% increase per year of education. So we interpret these as percentage. The last model I was going to run is this one, where in addition to having different slopes, we also have different intercepts. But I think I want to spend the last 15 minutes talking to you about your final projects. If you want to run this, you can. I've included code for this. The only addition is that we're including a separate intercept term by gender, which you've already seen. We're just adding this to the model. So this model gets very complicated. Like we have 4 different betas, beta 1 through beta 3. But each part is something you've seen before. What we're doing, we have a base intercept, our base wage, which is just the basic intercept. We have the baseline returns to education for the 0 group, which is just beta 1 times education. Then we have a separate intercept term for the 1 group, which is beta 2 times male. Claire?
Sorry, so that beta 1 is that just a 0, which is just, or is that like the average of that of the gender?
So if we have, the short answer is, if we have male having a separate intercept, then the beta 0 is for female. But in this model, where we didn't have a separate intercept term for male, this was the average for both groups. No matter the average, yeah. No matter the gender, it's the average at an education of 0. So the interpretation changes whether we have that additional, yeah. Yeah, great question. I love that question. Yeah. Okay, any others? So now that we have a separate intercept term, we have the average for the 0 group on the vertical axis. We have the additional intercept term for male, and then we have the returns to education given to us here. And then the last thing we have is the specific returns to education for the 1 group for male. So this is an additional intercept. The only new thing here is that we're including all of these components of our model in the same model. This is about as complicated as we're going to get with these interaction terms. Each one you've seen, and what we're doing is just combining all of them in the same model. I would probably not recommend this one as the best model, but it very easily could be. And I've given you the code to run it here. But I want to spend the rest of class talking about your final projects, so why don't we end class here? Next class, we're going to talk about numerical control variables. So that's what we're doing next time. And we're going to look at the Pittsburgh housing market. All right, hope you've enjoyed this white noise. My voice is now fried. So I'm going to be here the rest of class. I'd love to talk to all of you about your final projects. Treat this as 10 minutes to maybe check in with your partner. And then if you have questions, to chat with me about them. I'll be here until whenever we're done.